Welcome to Space Oddities, or should I say good morning. It's very early in the morning here in Spain. It's what is it now? It's 1:30 in the morning. And we're here this evening to bring you live coverage of the Japanese XRISM mission, the new space telescope, which is going to study the violent universe. And we're all very excited about this because it should prove to be a fantastic instrument to fill in lots of gaps in our knowledge about the X-ray universe. I'm joined this evening by Daz in the UK and Michael similarly in the UK. How are you guys?
Hello. Well, good morning. Good morning.
Yeah, we were determined to cover this because it's been delayed a good few times, and we've been ready every time to bring you the live coverage. So hopefully this time they'll nail it. Let's just have a quick look at what's going on in Japan. By my calculations, we've got just over 10 minutes to go before the launch, and we're taking our feed from JAXA, the Japanese Space Agency. But as we've got a little while to go, it's worth talking about the mission. Now, Daz, can you just give us a brief rundown on the mission itself?
This mission, which is it's actually if you look at the acronym, is XRISM, but it's pronounced XRISM, as you said, and it stands for X-ray Imaging and Spectroscopy Mission. Now, the Japanese, their acronyms actually say what they do on the tin, so we don't get all these obscure words and all that. But this is a very important mission, and I'll tell you why. XRISM is a joint mission of the Japanese Aerospace Exploration Agency, JAXA, and the National Aeronautics and Space Administration, NASA. But also, ESA has also provided hardware and scientific advice for this X-ray telescope, and XRISM will also act as a test bed for the Athena telescope, which is to be launched in the future. And then say a little bit more about this earlier. Now, the reason this should have been launched, I think it was about 2 years ago, and I'll just read this to you. As the only international X-ray observatory project of its period, XRISM will function as a next-generation space telescope in the X-ray astronomy field. Similar to the James Webb Telescope, the Fermi Space Telescope, and the Atacama Large Millimeter Array ALMA Observatory are placed in their respective fields. The mission is a stopgap, and this is why it's important. It's a stopgap for avoiding a potential observation period gap between X-ray telescopes of the present Chandra, XMM Newton, and those of the future, like the Advanced Telescope of High Energy Astrophysics, Athena, and the Lynx X-ray Observatory. Without XRISM, a period in X-ray astronomy may arise in the early 2020s due to the loss of Hitomi, which was another telescope observatory which actually failed. With the retirement of the Suzuka, which was another telescope, in September £2.50, 2015,
Bargain.
and the detectors on board Chandra X-ray Observatory and the XMM Newton operating for more than 15 years and gradually aging, the failure of Hitomi meant the X-ray astronomy will have a 13-year blank period in soft X-ray observations until the launch of Athena in 2035. This is what I said earlier on.
Wow.
I'm assuming this is a European adventure.
Yeah.
But there's some really critical stuff in this. XRISM will be the most powerful X-ray telescope in orbit, and it will be able to see the universe in X-rays with unprecedented clarity. XRISM is equipped with two instruments, Resolve and Extend. Resolve is a high-resolution spectrometer that will be used to study the detailed properties of X-ray sources. Extend is a wide-field imager that will be used to study large-scale X-ray emissions from the universe. XRISM will be the first X-ray telescope to use a cryogenically cooled mirror. And this is where all the new technology that's going to be coming in, and it's going to be, as I said, a test bed for future telescopes, X-ray telescopes. This will allow XRISM to see X-rays with much higher sensitivity than previous telescopes. It's like the James Webb MIRI bit on James Webb. It's going to be called down to nearly absolute zero to get this sensitivity. XRISM will be used to study a wide variety of astronomical objects, including black holes, neutron stars, supernova remnants, quasars, galaxy clusters, and the hot gas that fills the space between the galaxies. XRISM will also be used to study the evolution of the universe and the formation of galaxies. It will be a powerful tool for understanding the extreme environments of the universe and the processes that shape them. XRISM is a major step forward in X-ray astronomy. It will open up a new window into the universe and allow us to study objects that were previously invisible. Also, XRISM will help us to answer some of the most fundamental questions in the universe. So that's basically just a quick breakdown of what it's going to be doing.
Okay. Right, Michael, are you looking forward to this one?
Yeah, definitely. I just think it's good to see JAXA entering into this field of X-ray astronomy.
Yes.
Along with the usual Western countries, shall we say? It's good to see that, definitely.
Absolutely. And this mission is slightly unusual because there's a sort of a second component to this mission, which is a Japanese moon rover called Slim.
Yep, there certainly is.
Yeah.
Yeah, it's called. The title is Smart and Slim Moon Mission: A New Approach to Lunar Exploration, and it's a really fascinating read. I don't know if you want to talk about it now. How long have we got?
We've got 5 minutes.
5 minutes.
We talk about it a little afterwards, if you like.
Yeah, okay, then that's it. But there's some really fantastic technologies that have gone into this. It's also been done very, very cheaply using off-the-shelf parts from other missions. So yeah, it's a fascinating little thing. We'll talk about it afterwards. Yeah. And just one thing I will say about it, and it was something that surprised us with Changi 3, the actual lander is also a rover. And we actually saw Changi 3 lander do something very unusual this week. It hopped.
Yes, that's right.
And this lander will also do the same. But we'll talk about that afterwards because I think we're getting pretty close now. So
we're getting pretty close. So it looks a beautiful launch site. They've got a lovely day for it by the look of it. So this is all looking good. Let's join the Japanese commentary for the last couple of minutes of the launch.
37, 36, 35, 34, 33, 32, 31.
Or maybe not.
Yeah, they will be when they do explanations and they explain things. They do put up a translator.
Yeah.
But usually they're talking over each other, so it makes it a little bit.
Let me just get the sound back for a moment so I can balance it properly. Okay. Okay, we're just over 3 minutes from launch.
Yeah.
It seems
as you can see, it's venting nicely, and it's got.
88, 87, 87, 86, 85, 84, 83, 82,
Is she actually counting down, do you think?
180.
打ち上げ3分前です。It's 3 minutes to the launch.
All right.
全システムの電源が外部から内部に切り替えられました。
170.
The power has been switched to the internal systems.
So it's been switched to the internal system.
The first liquid hydrogen system has been pressurized.
Pressurized.
And I see we have a couple of viewers watching us this early in the morning, so thank you for being with us. Much appreciated for you to join us here for this fantastic launch.
Good daylight launch.
140, 39, 38, 37, 36, 35, 34, 33, 32, 31, 130, 29, 28、27、26、25、24、23、22、21、120、19、18、17、16、15、14、13、12、11、110、109、108、107、106、105、104、103、102、101、100。
Well, it's got closer than it did the other day when it was cancelled.
96、96、95、94、93、92、91、90、89、88、87、86、85、84、
2段液体酸素系、液体水素系、準備完了。The second stage liquid oxygen and hydrogen system has been visualized.
74、73、
1段液体水素系、準備完了。
69、68、67、66、65、64、63、62、61、60、59、58、57、56、55、
The cooling
54、
water system for the flame deflector has been activated.
50、49、48、47、46、45、44、43、42、41、
40 seconds.
39、38、37、36、
And this is an H2A rocket, 202 rocket. This is.
That's become the sort of the Japanese workhorse of the moment, hasn't it?
Yeah.
21、20、19、18、17、16、
15
15、
seconds.
14、13、12、
Flight mode on.
10.
The flight mode is on. 同様電池起動。The thermal battery has been activated. 全システム準備完了。All systems are go.
Yes.
There it goes.
Main engine ignition. Further BA 点火。Lift off. Solid boosters ignited. Lift off. プリズムスリムを搭載した H2A ロケット47号機は2023年9月7日午前8時42分11秒に種子島宇宙センターから打ち上げられました。We have a liftoff of the H2A launch vehicle number 47 from JAXA Tanegashima Space Center at 8:42 and 11 seconds a.m. on September 7th Japan Standard Time. 打ち上げ以降、ロケットの管制は吉信発射管制塔から竹崎総合司令塔に引き継がれています。Following the liftoff, the operation control of the H2A has been switched from Yoshinobu Blockhouse to Takesaki Range Control Center.
Look at it go.
60、
打ち上げ後、
Yeah, he ain't
1分
hanging
が
about,
経過
is
し
he?
ました。
Nope.
It's 1 minute into the
Waited long
flight.
enough.
Well, it's finally on its way.
70、
So far, so good.
Looking good.
ロケットは現在、東方向の太平洋上へ飛行しています。The H2A is now flying above the Pacific Ocean to the east.
83、84、85、86、87、88、89、90。
SRBA 燃焼終了。Solid boosters have burned out.
Yep, they certainly have.
Mm-hmm.
And separation?
Yeah.
Yes.
110、
SRBA 分離。
12、
Solid boosters have been separated.
15、16、17、18、19、
But yeah, we get the idea. You can count. Are we going to get any pictures from the rocket itself, I wonder?
That's a point. Might be way over the Pacific now.
Yeah. Yeah.
I'm
That
comparing
comes the
it.
data. It's all in Japanese. I'm losing it. Still making a hell of a noise, though, isn't it?
It only does seem to be hissing a lot, or is that something on the ground?
I should think that's something on the ground now. It doesn't sound like a rocket in flight.
So what orbit is it going to, Andy?
小笠原局でのロケット追尾が開始されました。
Ogasawara Station has started tracking the H2A.
Ah,
There we are.
so what orbit is it going to, Andy?
I don't know.
It's going to a geosynchronous orbit.
第1段エンジンの燃焼は正常。制御系飛行経路も
Well,
正常。
XRISM is.
ロケットは順調に飛行を
Let
続
me
けて
just
います。
find it. I have it here somewhere. It's going to be a low Earth orbit, geocentric orbit, 550 kilometers up.
Nice.
So that's where the actual telescope's going.
Yeah.
But of course, the other part of it, the SLIM, the moon lander, will be going a bit further than that.
Just this.
Yeah.
Just a tad, yeah.
Maybe like a quarter of a million miles.
Right, so we got
Something like that,
we
yeah.
got the first stage engine cut off.
Ah, right.
I've killed the commentary because it is all in Japanese.
Yeah, that's true.
Yeah.
Not that, of course, that there's anything wrong with that, but we can't translate it for you, so there's not much point in having it. If you're listening in Japan or watching us in Japan, sorry, but there we are. I can just about read the. I'm just going to maximize this so that perhaps we can get to read some of the English on the screen. Here we are. That's a bit better.
All right.
Right, so we're coming up to, or down to, actually. It's strange. The progress is going down, not up.
Yeah.
So we're. Oh no, the next stage is the first stage engine cutoff. That's what's coming up next. And then we've got the separation of the two stages, the second stage ignition, the second stage end of ignition, engine cutoff, the XRISM separation, which by the look of that is probably going to come up in about 10 minutes or slightly longer. And the lower payload fairing jettison, that would be the SLIM payload, I presume. Second stage ignition 2, second stage engine cutoff, and SLIM separation. It's a little bit of a shame that we've had no video from the rocket itself. I think we get so.
Oh, that is a shame.
Yeah.
Considering some of the technology they've actually incorporated into the actual missions themselves.
Oh, yes.
You would have thought they could have had, strapped on a couple of GoPros or something.
Yeah.
So, oh well, never mind.
But
yes, it's on its way, and it always fascinates me when we see these rockets with these solid rocket boosters strapped on the side. Is that once those are lit, of course they're not controllable. They're dumb. They once you lit them, that's it. They're going. They're not. There's no way you can stop them. You can't control the. There's no throttle control or anything. You can't cut them off. Once they're lit, they're going. Is how fast these vehicles move off of the launch pad once they're lit.
Yeah.
They really do throw out a lot of power. And of course, there was a time because they now use them on things like, the space shuttle was a good example. Well, maybe not actually. And the SLS, they put them on there. But before then, they would not rate solid booster rockets for human travel. They weren't going to put any astronauts on top of them with solid boosters.
Yes, that's true.
But of course, as the rockets got bigger and things got heavier, they've had to do that. But they proved so successful that we can't really do without them now. But as I said, as soon as they're lit, those things are out of there.
Yeah.
They're not going to hang about. They're gone now. So and of course, So again, with the Japanese, is most of this is expendable. Well, it's all expendable, which is very much a shame. But well, people, even everybody's now realizing they've got to go recycle these rockets like SpaceX do. SpaceX have led the way. They've shown it can be done. The Chinese are doing exactly the same now.
Yes.
The Indians have got a program for recycling their rockets. So it's the way to go. And also it just brings the price down dramatically, very much dramatically. So yeah, that was a good launch, actually. Good launch.
Yeah. And look how far it's gone in 6 minutes.
Yeah,
absolutely.
Yeah,
I think we're so spoiled by SpaceX bringing us back 4K video from the rockets when they launch. You know, they're like the IMAX of space flight, really, aren't they?
That's right.
And you know, SpaceX are really leading the way in everything in the space industry. And but what's lovely is to see nations like India and Japan staking their claim in the space world. Also, of course, it's lovely to see another rover on its way to the moon. We've had two in quick succession. You know, we went for decades without anything, and now we're, you know, the pace of especially lunar exploration is really ramping up. There are so many missions planned for the moon. I can't remember how many, but over the next 2 years, there are lots of missions by various countries to the moon.
It's like waiting for buses.
Yeah, absolutely. Yeah, absolutely.
Yeah. Because I mean, if you want, I can talk a bit about the lander, if you like, Andy.
Absolutely. Let me just sort this out then. Let's just put this back on the screen. And let's just do that. There we are. So let's move on to talk about Slim.
Yeah, JAXA Smart. Now, as I said, as the title says, it's Smart and Slim Moon Mission, a new approach to lunar exploration. Now, the innovation that's gone into this is absolutely fantastic, and this is just a few of the examples. The mission is named Smart and Slim because it is designed to be small, lightweight, and efficient. That will use innovative technologies to explore the moon's surface. SLIM stands for, and remember I said about their acronyms, Smart Lander for Investigating the Moon.
Perfect.
It's what, as I said, it's what it does. It's what's in the tin. It has also been known as the Moon Sniper. And the reason for this is SLIM will be Japan's first lunar surface mission and will demonstrate a precise pinpoint lunar landing. During its descent to the moon, the lander will recognize lunar craters by applying technology from facial recognition systems and determine its current location from utilizing observation data collected by the Selene Lunar Orbiter mission. Selene, SLIM aims to soft land with an accuracy range of 100 meters. In comparison, the accuracy of the Apollo 11 Eagle lunar module was an elliptic, which was 20 kilometers or 12 miles wide in downrange and 5 kilometers, 3.1 miles wide in cross range.
Wow.
So they're actually aiming for some pretty good precision. And as I said, this is used, and they're going to try and do this with facial recognition software that we use on the Earth. So they're using the technology that's available, and they're adapting it, which is a fantastic idea. The Smart and Slim Moon mission is a new approach to lunar exploration by JAXA. The Smart and Slim Moon mission is a very affordable mission, costing around. Anyone got any ideas in dollars?
60 million.
Michael?
90 million?
$20 million.
No way.
Yeah, $20 million. The The mission is a collaboration between JAXA and several Japanese universities and companies. The Smart and Slim Moon mission consists of 2 parts. A lander that will touch down on the moon surface. And this, as I said, is also going to be a rover as well, and it's called Lunar LEV-1 hopper, because as I said, what will happen is that this will also be the orbiter part of it. When it reaches the moon, it will orbit the moon for 2 to 3 weeks,
right.
Then land on the moon surface for several days. Right. So it's the actual landing and the duration is about 7 days.
Daz, if I could just interrupt you for a moment, let's just go back to the coverage of the mission, because we've had a few events happen. The separation of the first and second stage, the second stage ignition, and the subsequent cutoff. We're coming up very shortly to the actual XRISM separation from the launch vehicle, and that's coming up in just a few seconds, actually. And if the progress bar gets beyond that, I think we can say, yes, it's happened, because the next event now is the lower payload fairing jettison. So XRISM has actually separated from the launcher by the look of it.
That's good.
Things, just give me a second, just let me confirm this. Yes, I believe the progress bar is still moving forward. Let me just see if there's any English commentary for this.
分離を予定しています。
The separation of Sulin will occur in about 47 minutes into the launch. Until the next major event, there will be an intermission.
Oh,
竹崎総合司令塔からの実況放送は
right. So get the Kioras out. It'll be an intermission.
Yeah. So obviously the XRISM has separated.
XRISM has successfully
and then,
separated.
Yeah.
And
So that's fantastic. That's good news.
On its way.
Yeah.
That's fantastic.
Yeah.
For those,
So it does.
That's
Anyway,
fantastic. So
can I just say, sorry. Yeah. Oh.
Okay. So let's just carry on with.
So as I said, it's the LEV, the Lunar Excursion Vehicle 1, which is a hopper, and I'll explain that in a second. That is also going to be the orbiter to begin with. It will orbit the moon for 2 to 3 weeks, then land on the moon surface for several days. That's what's planned. The actual LEV-1 carries direct-to-earth communication equipment, 2 wide-angle visible light cameras, small electrical equipment, and UHF band antennas taken from Minerva and Omitanashi systems. So basically it's systems off of other projects and other probes. So as I said, it's off the shelf. It's technology that's been proven, and they're just bolting it together, and they're making themselves a small lander. And this is quite, as I said, yeah, very small. It was on the LEV-1. There is a second lunar excursion vehicle, which is LEV-2, and this is the size of the palm of your hand. Now, as we said earlier, they joined up with industry, with universities, and even toy makers, and they've developed this rover. And it's, as I said, it's the size of the palm of your hand. It's fitted with 2 cameras to investigate the regolith and ejector from craters. So that's all it's really going to be doing on this part of it. And it's actually, the initiative comes with it here. If it encounters any sort of like obstacles, it can actually change shape. So I don't know if that means it's going to turn into a little transformer or whatever. I don't know.
From what I was reading about it, I think that's basically it. It is like a little transformer on the moon. It's amazing.
Yeah,
now,
so it can adapt itself for the terrain.
Now, talking of terrain, on the screen you can see the actual landing site, which is a small crater called Scioli, which is inside a larger impact crater called Cyrillus, and that's on the near side of the moon. And if we have a look where that actually is, it's there. I don't know if you can see this.
Yeah, it's just at the. If you see where it says Mare, not Nectarius, if you look directly left of there, the first big crater you come to on the edge, that is Chrysalis. And the smaller crater is inside that one.
And in fact,
and then if you go to the next slide, it will show you exactly where on the moon it is. It's on the equator.
We're here. It's
about there. If you look where on the right hand side, just below the equator, you'll see Mare Nectarius, and that's where it's situated. So it is literally on the equator. So
fantastic stuff.
It's on the equator.
Okay, well, thank you for those.
Yeah.
Let's see what's going on. More talk about the mission. As I said, they're going through an intermission at the moment until the next major event. The next major event is coming up in about 20 minutes. But that will be the release of the slim vehicle on its way to the moon. And obviously, it's going to take, I don't know how long it's going to take to get to the moon or what sort of trajectory.
No, I've got no idea of that. No. I couldn't find any information on that, I'm afraid.
No, there we are then. So, Michael, any thoughts?
Just again, countries like Japan doing this sort of thing when we're so used to Western countries like America or even Russia doing scientific missions like this. So it's good to have a new set of eyes, shall we say?
Absolutely, absolutely. Well, there we are then. That's the new X-ray telescope, which is going to hopefully fill in lots of holes about our knowledge of the X-ray universe. Safely,
this was needed.
Safely on its way to its orbit around the Earth, and everything appears to have gone exactly to plan. So many congratulations to Japan. Thank you for joining us this evening, and we do appreciate you being here. We will be back on Saturday afternoon, UK time. What time is that, Daz? Can you remember?
I think it's about 1:45, but check the timings because it's an Atlas V mission that was cancelled due to the hurricane.
Right.
It's a secret mission, so nobody knows about it except us. So don't tell anyone. Except your friends and that, and get them to log on. But it's called Silent Barker.
Silent Barker, yes.
And it's a military one, but it's worth watching because it'll be one of the last Atlas V's to actually fly.
Yeah. Yes, and this is why we particularly want to cover it, because the Atlas V has been a real workhorse of a launch vehicle. Incredibly successful, very reliable. And it's coming to the end because America is no longer allowed to use Russian rocket engines. So there are very few Atlas rockets left because they do use Russian rocket engines. And of course, it's not just the fact that they can't use them, they can't maintain them because Russian technicians are no longer involved in maintaining those engines. So even if they had many more in stock, as it were, they probably couldn't use them because the Americans don't have the expertise and the knowledge that the Russian engineers do. So this will be one of the last flights of the Atlas V. I think there's only one more after this, if I remember rightly.
Yeah, either one or two. So what's Psyche going on?
Falcon Heavy.
Falcon Heavy.
Falcon Heavy.
Yeah.
Because I think that was I think they've, because the way things have all happened, they've had to do some switching around of rockets and that now. So
it's the first Falcon Heavy for NASA's interplanetary missions.
Yes, indeed.
Yeah.
Well, we'll be back here for the coverage of that launch on Saturday afternoon. But if you can't make that, don't forget our usual Monday live shows at 8 p.m. UK time here on Space Oddities. Coming up this coming Monday, we've got a fun night in store. It's quiz night, backed by unpopular demand. We're going to have another quiz night, and it's going to be a lot of fun. So we hope you would join us for the quiz. It's an astronomy and sci-fi quiz this time. No, don't worry. You'll be glad to know there are no obscure questions about the fourth Doctor Who. So it's got much more of an international flavour, so everybody can take part. So we hope you will join us at 8 p.m. UK time here on the channel for our normal Monday live stream. And it's quiz night, and it should be a lot of fun. So
it's a shame about that question, because I could have answered that when it was Bruce Willis, wasn't it?
Yes, probably.
The name we hate to hear.
Absolutely. Right. Yes. So there we are. So from Daz, Michael, and myself, thank you so much for being here, and we do appreciate it. And have a fantastic weekend, everybody. And if we don't see you on Saturday afternoon here on the channel, keep your eye on the channel. If you subscribe and tick the notifications, you will, of course, get notified whenever we're going live. But your subscriptions and likes for our videos are much appreciated, and they do help us get noticed by the YouTube algorithm. So that's fantastic. Yeah. So it would be much appreciated if you could like and subscribe. So if we don't see you on Saturday, hopefully you'll come and join us for quiz night on Monday. All right, then. Take care, everybody. Thank you for being here. And from Daz, Michael, and myself,
thank you.
It's good night.
Bye for now.
Bye.
Keep